Okay, everyone. So the first 4 days of this week is really not the actual curriculum for this course, but it's just the basic math skills that we all need to know to actually be able to solve the questions when we start, the new material next Monday. Today we do rounding. Okay, what does rounding or what does rounding a number mean? Okay, it means taking a value, a number, and finding what other value is what furthest or closest to it. What do you think? Actually, closest. So, for example, if I say that you have $3.999, practically, how much do you have? That's the whole idea. Get me the value that seems to be the closest to it. Okay. So, finding what value is closest, closest, or you can say nearest. Just don't say furthest. Nearest. Okay. To it. So we can use it instead of the original value. Why do you need to round sometimes? Well, sometimes, like, who cares if you have $3.99? Just tell me practically you have four, and that basically will be the end of it. Okay. So why do we round sometimes? To make our lives, calculations, and conclusions much easier. Sometimes. Okay. By the way, sometimes you can't round. Often you can. Okay. And would you do with money or areas or lengths? Yeah, you can round. Okay. Um, Here are some examples where you probably do rounding without knowing it. So someone tells you that they have $16.98. In other words, you have $16.98. What could you tell them they have so the number becomes simpler? You got it. That's it. 17. So you would say $17. 17. Remember always, everyone, I used to make this mistake. I used to put, because when you say $17, I used to put the dollar sign after the number. Nope. Dollar sign is always what? Before. But cents is always what? After. Okay? So 17. Now here's the thing. Jalil, you said 17, right? That's correct. Could you have said 17.00? Could you have just, instead of saying 17, say 17.00? Technically, yes, it is the same thing. However, the whole idea is to make lives easier. So we're going to say we do not need to put the 00 cents. Yep, just $17. We understand that it is 17 and no cents. Good. Perfect. All right, next one. You buy for your baseball team 31 baseball bats. What could you say about how many bats you got? Could you say that you bought 40 bats? You didn't buy 40 bats. 40 is very far from 31. You could say you bought what? Exactly. Even though you did round down, so you might actually tell that you bought fewer bats than you did, but at least you are closer with 30 than with 40. Perfect. You could say, sorry, 30 bats. So far, so good. Okay, finally, something I always do, and most teachers do. I'm going to say most teachers. Let's say that on a test in this course or another course, you got 87.2% on the test. You got 87.2. How do you think the teacher is going to record your mark in their software? Depends on how nice the teacher is. What's one rounding that's possible for a teacher to put this as? So a teacher could say 87. That's fine. What does that mean? The teacher rounded up or down? Technically, they ditched this point 0.2, so they were like, nah, they didn't make it across to 88. I'm going to give them 87. How could another nicer teacher round this up? Someone other than Jalil. You get it if no one else wants. Huh. Come on, everyone. What if a nice teacher wants to round this up? What possible up rounding could be? Ty? See, that's the thing. I'm leaving up to you. That's the whole idea. See, I like what he said. Wait. I like what he said because unless I tell you how many numbers you have to round up to, I'm kind of leaving it vague. So what did you want to say? Oh, see, that's one way. What would you have said? Since you did ask, does it have to be a whole number? Hmm, 80. Okay, but come on, think of a nice teacher. What if there's a nice teacher who doesn't want to give decimals? They just want to give you a whole number. Anyone? 88? 90. Technically, 87 is closer to 90 than to 80, right? Again, it depends on what the teacher wants to do. All right. I'm the kind of teacher who, if you are 88 or 89, I always push you to the next zero. Okay. So if you get 88, you get 90. You get 89, you get 90. Because my philosophy is, if you got 88 on the test or in the course in general, that's like, a couple of bad quizzes that didn't go so well. You deserve it. Okay. So because this was a good discussion, they would most likely record. Okay, they could 87 or 88 if they want to push it to the next one, or even if they want to push it to the next 10, 90%. It all depends on what restrictions or conditions they have. Okay, all right. So this goes on to show you that rounding can be done to values that might have decimals in them, like this guy, or no decimals, like whole numbers, like this guy. 31 doesn't have decimals. Well, it shouldn't. I mean, you can't really buy 31 and a half bats. You would just be either 31 or 32. Okay. Some things have come in whole parts, and some things could come in what decimal parts. Okay. So now the question is, when you are rounding a value, how do you decide what the closest value to use should be? For example, why did we round, for example, 87.2 to 87 and maybe not 88? Why did we run 31 bats to 30 and not all the way up to 40? Why did we run 16.98 to 17 and not down to 16? Okay. Although stores have different ways. I mean, usually they round down when they give you change. So they kind of take the hit for you and they give you more change. That's when we switched from pennies to just 5 cents or a nickel. Okay. So let me teach you the rules now. Okay, everyone, pencils down. We'll get to highlight and everything. And this is recorded. So feel relaxed. Everything will be posted. So what if what you're rounding is a what? Whole number, which means what? A number with no decimals. A number with no decimals. So let's write this down. No decimals. No decimals. Okay. When you round to no decimals, I have to tell you how much you want, or sorry, how much I want you to round up to, or round to. I'm not gonna say round up or round down, because that's a choice you have to make. If you want to round to the closest what? The closest what? 10. What do you do? Again, you have 2 pages of examples, so if the theory doesn't make sense, no problem. We'll put it to the test. You start from the right side of the number, and you draw a line immediately before the what? The first digit of the number from the right. So, by the way, rounding is always from the right, and you move this way. Okay? So you put a line immediately before the first digit in the number from the right. In other words, draw a line at the what we call, I know if you remember this from grade school, the tens place or the tens spot. There are tens or what it starts ones, tens, hundreds, thousands, and so on. Okay. If you want to round to the closest what? 100, then you still sketch a line or put a line, but not after the first digit, after the what? Second digit. If you want to round to the next what? Or sorry, to the nearest what? Then you put a line, not after the first, not after the second, but after the what? Third. And now you get the process. So basically, depending on how many zeros there is, if there is 1 0, you put it after the first. 2 zeros, you put it after the second. 3 zeros, you put it after the third. And as the number gets big, you can actually put it in the next 100,000, million, and so on and so forth. I'm not going to give you these numbers. Probably most of the time, we're going to stick to 1,000, 10,000, so on. But the process is the same. Now, here's where rounding is actually done. Once you put the line, everyone, eyes on me. Once you put the line, if the digit after the line is what? 0 or 4, nothing happens to the what? To the number before the line. Do not change the digit before the line. All digits after the line become what? 0. What if the digits is what? Then this is what we round up. Yes. The digit before the line goes up by 1, And all the ones after it become what? 0. Okay? So this is if we're rounding what? This is if we're rounding what? Numbers with no decimals. What if I give you numbers with decimals in them? So let's read the rule. By the way, the rule seems to be very similar. If you want to round to no decimal places, you draw a line where immediately after, we have decimal points now. Immediately after the decimal point. What if you want to keep one decimal? Then you draw a line immediately after the what? The first decimal. What if you want to keep two decimals? Then you draw the line after two decimals. Decimals, I always find out that decimals are easy because you just decide how many you want to keep and you cut it right there. Yeah, you literally, but because we know you're going to have to stop. So you tell yourself where you're going to stop. Once you draw the line, what do you have to decide? You're going to have to decide, are you going to keep the number the same or round up? Guess what? The same exact rule. If the digit after the line is 0 or 1 or 2 or 3 or 4, nothing happens, and you remove all the digits after the line because you don't show them. You're not supposed to show them. You said I want to round only up to 2, which means everything after the 2 decimals is ditched. If the digit after the line is 5, 6, 7, 8, 9, two things happen. The digit before the line goes up by what? By the way, it only goes up by 1. And then you remove all the other digits after the line. Okay? All right. Lots of talk. Let's actually what? Put it to the 2 pages after. Okay. So flip the page, everyone. So let's do some rounding here. Okay. All of these numbers on the second page are what? Whole numbers, which means are you going to use the second rule or the first rule? The first rule, like the first block on the first page. Okay. I'm going to do a few, and then I'm going to start discussing with you how we do each one after. So let's do the first one. 6,000. Everyone, pencils down. Just let this sink in. 6,547. Apparently, we want to round it to the nearest what? Perfect. How many zeros does 1,000 have? 3. So what does that mean? Where do you place your line? Or technically, by counting backward 3, right? Yeah. By count. So not here, not here, not here. Where? Yes. So you have to count 3 zeros, 3 numbers. Got it. So the first thing we're going to do is this. Go ahead, write with me. So 6, 5, 4, 7. I'm going to choose a different color for my line. It's red, and it's right here. Okay. Got the line done. What's the second step? I look at the digit after the line. Can someone tell me what's the digit right next to the line? What is it? 5. What does the rule say if if the digit after the line is 5, 6, 7, 8, 9, or 9? Exactly. This number goes what? This number goes up. And all of these numbers become what? Zeros. You always go up in the number right before the line. You see, it's weird. You use this one to decide, but you end up changing this one. So so that means because of this guy, the number becomes 7. Do you need to show me the line now? Nope. The line is only used to what? To decide where the cut is. The final answer should have no line. The final answer. Okay. Let me ask you a question, everyone. Pencils down. If you have $6,447, are you closer to 6,000 or to 7,000? Think. Okay. Here's another question. Okay, I'll actually say it a different way. If you have exactly 6,500 dollars, are you closer to 6,000 or to 7,000, or are you exactly in the middle? Again, the number now is 6,500. You're exactly where? In the middle. You're as far from 6,000 as far as you are from what? 7. Does that make sense? You're right in the middle. But how much is the number they're giving you, or I'm giving you? 6,500. So am I, okay, Jalil, tell me, should I move more to this side or more to this side? Slightly. I just got closer to what? To 7,000. Is it making sense now? See, imagine yourself right in the middle. And then if you're more than 6,500, I don't care, even if you are, if you're more by $1, you are closer to what? To the 7,000. Always imagine it in what? In a distance money sense. Perfect. Okay. Next one. 43. And we want it rounded to the nearest what? How many zeros does 10 have? 1. So where is your line going to go? One digit this way. Yep, you got it. So write the number. Oh, sorry, it's 43. And 10 means right here. What's the deal with this number? It's what? It's below 5. It's one of the 0, 1, 2, 3, 4 choices. If it's below 5, like 3, what happens to this number? Does it change or does it stay the same? Oh, wait a minute. I'm talking about this number. Not yeah, that number. Because you always have to decide what happens to this based on correctly what you just said this one on. What? It just keeps it at 4. But what does the 3 become now? There you go. Does that make sense? Let's think about this. 43. 43. Okay. Where is the number exactly between 40 and 45? Sorry, I just said it. 40 and 50. 45. If you're 45, you're as far from 50 as you are from 40. That's if you're at 45. If I'm at 43, where am I? More to this side or more to that side? I just got closer to what? 40. So always imagine it this way. By the way, I'm never going to ask you to sketch. Some teachers require you to sketch like a number line, like, you go like this, you show 40, you show 50, and you kind of have to have a good scale because you should show that the 43 is in this region of it. Like you might point to it here. Yeah, you can tell me all of that by just showing me the line and telling me, oh, 3 gets this one to stay as 4. And that's it. Okay? All right. How about this one? How many zeros are we looking at? 3. So I'm going to write my number first. 6, 5, 4, 3, 2, 1. And where am I going to place the line? The red line, the cutoff line. Hamad, where am I going to place it? Okay, Hamad, I'm going to move my pen. You tell me when to stop. Hamad, do you agree? Here? How many people agree it's here? How many people disagree? How many people say I should move it somewhere else? Jake, where should I move it? Here? Here? Or the other way? Yes. Remember, you just need, how many zeros do we have? 3. 1, 2, 3, and you place it right. Okay. Well, yes, you need to see it more because every number introduces its own trick. Okay. Which number am I going to look at to decide what happened? The 1, the 2, or the 3? Which, the 3. You never look at you look at the ones right here. What does 3 do? Something or nothing? Okay, I mean by that, does the 3 bump something up or does it keep it where it is? A 3. Exactly. Remember, everyone, look. Let me just refresh your memory here. 0 and 1 and 2 and 3 and 4, they what? They do not change the digit before the line. Great. Just like you did not change the digit here. Nice. So the number becomes 6, 5. This stays as what? 4. And all of these things become 0, 0, 0, 0. All right, we're on a roll here. 10. Here's my number. 5, 4, 2, and 9. Where should my red line go? Sorry. Ex- exactly. One spot, and that's it. What does a 9 do? It bumps up which one? The 2 or the 4 or the 5? Yeah. Why did it? What? It doesn't touch this one, or does it touch what? It touches only this guy, and this goes up to what? 3. And what does the 9 become? There you go. And it makes sense. If you are $5,429, and you're giving me the value, or the money in bills of 10, you're gonna run me up to $5,430. 5, 4. So I'm just gonna. This one goes up to 3 and 0. Good. All right. Because I want to assign you some. Remember, I don't assign homework. The only homework I assign is basically anything that we don't do in class. That's it. Or anything that I stop until, you know what, just work on this, because I'm going to release the solutions later on today. Okay, so I'm going to do this row. And actually, you know what? Let me do this big row with you. And then you get this whole row as your homework. All right? Okay. So let's do this here. Okay. 85,500. So I'm going to write it 85,500. And we are looking at how many places to cut. Remember, if you have a certain number of zeros, you just go by that number of zeros. 3, you just go 1, 2, 3, and then you cut. So 1, 2, 3, cut. Okay, now I'm going to have to make a decision. What does the 5 do? The rule for rounding is 0. If this number is 0, or 1, or 2, or 3, or 4, then it does what? Then it does nothing, and it stays the same. But if it's 5, 6, 7, 8, 9, what does it do? It bumps it up by just 1. So this number will become 86, and all of these numbers will be zeroed out. Okay, let me just discuss something quick with you here. I know this probably does not, everyone pencils down. I know this probably does not sit well with some of you. It didn't when I first took it. Why would you say that 85,500 is closer to what? How much? It's like telling me, I hope you can see it. Yep. Everyone, it's like telling me that if I'm standing right here, what's the number I'm standing at? Exactly. 50. No, sorry. 50. That I am closer to 100 than to what? 0. which is weird because where am I when you stand at 50? Where are you exactly? Exactly in the middle. In math, they have decided on a rule that if you do make it to the middle, they will always say that you are closer to the what? To the bigger side than the what? Smaller side. So that's why if someone's, and again, the argument is if someone has $85,500 in their bank account, if they have a number line and they stand, they should be, everyone eyes on me, they should be as far from $85,000 as far as to $86,000. So why do we say that they are closer to 86,000? We just said they are the same distance. They just had to what? Come up with a rule and say once you get to the half distance, you are we are going to count that you are closer to the what? To the bigger side than the what? Than the smaller side. Okay? Again, it's how rounding is in business and finance. So we just have to get with the rule, I guess. Okay, but it's always been a weird thing to justify. Okay, next. One, green. 14302. We're rounding to what? To the nearest what? So how many numbers do, sorry, I shouldn't say number, I should say digits. How many digits are permitted? Just one. So that means you got it right here. What does a 2 do? Does it do anything? Nope, it doesn't, which means this number is not big enough to bump this guy up, which is the why I'm going to take this arrow because it doesn't. Oops, sorry. It doesn't bump this up. So that means these numbers stay the same, and this one turns into a 0, which makes sense. If you have $14,302, you are closer to $14,300 than to $14,310 and so on. All right. So far, so good. 2, I've got to go blue this time. 2, 5, 4, 4, sorry. Yeah, oh yeah, 4, 4, 8, 9, 1. Let me compress the number a little bit. Yep. This is an amazing machine. I, I love it. Nearest 100. So how many spots before I do the line? Two. Remember, just the number of the zeros. That's fine. It'll 1, 2, cut. What does this 9 do? It bumps up. So this, let me just put it inside of the circle. This 9 is going to bump up this 8 to a 9 itself. So 20, 5, 4, 4, 9. Is this correct? Okay. What am I missing? I'm missing one more zero. See, you have to put as many zeros as there are spots that will be zeroed at after. There we go. All right. Wow. Nearest 100,000. That's fine. Same rule, but the number is just long. 1, 7, 4, 0. I just don't want to do a mistake. 4, 6, 3, 2. How many digits am I going to cut the line after? Just count how many zeros there are. 5 digits. So 1, 2, 3, 4, 5, and you cut. What does this 0 do? It makes the number stay the same, which means this 4 will not change. Great. So my number will be 1, 7, 4, and how many zeros? Oh, exact. That's it. All of them. Exact. By the way, think about it. Two zeros, two zeros, 1 0. Well, it might seem like you have two zeros here. Yeah, I do. But one of them was already a 0. Okay? So basically, you just have to turn all of them into 0, 0, 0, 0, 0. That's it. Does it make sense how we round whole numbers now? You just have everyone. Okay, so let's just take home message. Two take home messages. Number one, the number of zeros tell you where to make the what? The line or the cut. Okay, but that's only what? 50% of the game. That's only 50% of the battle. The other 50% of the game or the battle is to decide how this number is going to affect this number. How this will affect this. How this will affect the one before. How this will affect this one before. You only look at the one before, sorry, I guess after or before. That's it. Nothing after those, nothing before those. Awesome. Okay. No need to finish the homework once today. Sorry, I mean right now. Let's go, everyone, to the third page and round us some decimal ones. Okay? Which I always found to be easier process than rounding what? Whole big numbers. Okay? So let's go to the third page. Okay. So here is a list of decimal numbers. They could be money, they could be length, they could be weights, they could be anything that could be measured, like a scale, for example, or so on. Round each value as indicated. You have different ways, just like the first one, and show how you applied, which means show me the cut. Okay. First one, 32.6. Let me just write it down. 32.6. I am asking you to round it to what, everyone? Nearest what? Which means don't show any decimals. So how do you do it if you want to show no decimals? You put the cutoff right at the decimal point. Right at the decimal point. Okay? Let's do it. By the way, I don't care if you put it right before it, right at it, right through it. It doesn't matter. Just put it somewhere right here. Okay. We're going to do the same thinking we did before. What's this number? Sorry, digit. What's this digit? What does a 6 do to the one before it? Bumps it up. So what would the number be? You got bumped this guy up by 1. So it just becomes what? 33. That's it. 33. Think about it. If you are, everyone, eyes on me. If I'm at 32.5, look at me. If I am 32.5, I am as close to 32 as to 33, right? If I'm at 32.5, I'm as close to 32 as I am to 33. What if I move to 32.6? I'm closer to what? Again, everyone, look, eyes on this. 32.5 right here. Everyone, 32.5 right here in the middle. What if I'm 32.6? Where did I move? Closer to the 32 or closer to the 33? There you go. You got it. So we're going to round this guy. Sorry, use this guy to bump this guy up. So the number becomes 33. Okay. What did we used to do in the second sheet? We used to write all the numbers after the line as what? As zeros. But everyone, remember there's a problem. If you put a 0, then you're showing me a what? You're showing me a what? A decimal. I said don't show any decimals. So whenever you have no decimals to show, even if you're tempted, don't show it. So just stick at 30 what? Just stick at 33. 33. So if someone says I have I weigh 32.6, I have like a child weighs 32.6 kilos, you gotta be like, oh, so that's the closest to a whole number, 33 kilos. Done. Okay, next one. What's the number we have? 73. Let me just zoom in. 73.414. Huh. Apparently, I want you now to show how many decimals. How many? So what does that mean? So, okay, here's the thing, everyone. If I want you to show two decimals, that means I want you to show this guy and also what? This guy. You're gonna cut here. You see how things are different now? Am I moving this way or this way? I'm starting at the decimal point and moving as many decimal as I'm asking you to show. So I'm asking you to show two decimals. Great. Cut it at two decimals right here. What does a 4 do? Or so basically nothing, right? So that means the 1 will stay. Great. So that means it will be 7, 3, 4, 1. Do I show a 0? Who said no? Why not? Exactly. If I show a 0, technically I'm showing how many decimals? You got it. That's what you always have to ask yourself. If you are in doubt, put the 0 and then look at the question. Wait a minute. We're supposed to show 2. Oh, we don't put zeros anymore. Done. Because okay, just to everyone, just to enforce this rule, remember what we said here. Everyone, let's just go. You don't have to go. I'll just go up to the first page. We did not say put zeros. We said what? Remove the digits after. Don't put them as zeros. Just remove them. That's exactly what we do when we don't show them. We just remove them. So we just remove it and don't show it. Done. Okay. Next one. 49. 49.4637. How many decimals am I asking you to show? 3. So that means, look, everyone, I'm going to show this one. I'm going to show this one. I'm going to show this one. That means my cutoff line is right here. 2. Cutoff. What does a 6 do? What does a 6? It bumps anything right before it up. So that means my new number, or rounded number, I should say, would be 49. 4 stays, 6 stays, and the 3 becomes what? 4. Are you showing 3 decimal points? You sure are. 1 decimal, 2 decimals, 3 decimals. You got it. So it's the same rule. You're just applying it in a slightly but significantly important different way. All right. Oh, by the way, before I do the next one, everyone, just eyes out the screen. Sir, I'm also showing you different ways of people asking you to round. Sometimes, by the way, I'm a big fan of using this way, telling you explicitly how many what? How many decimal places to show. Because you look and you get the question right every time. There's another way to tell me to the nearest what? 1,000. Again, some people use it like that. I will alternate between both, but you can tell definitely. I guarantee you that my favorite one to make your life easier. I'm always gonna tell you how many decimals. Okay. However, how can you always remember which one is which? Well, 3 decimals. What has 3 zeros? A what? 1,000. What has 1 zero? A 10. What has 2 zeros? So that's one way to remember it. Okay. But I'm definitely gonna go with the first one, like this way. It's easier for you and me. All right. Next one. Let me just squeeze this number a little bit. 71.841. How many decimals are you allowed to show? Just one. Well, that means I'm only going to cut right here. What does a 4 do? Exactly, which means the 8, okay, thank you. The 8 will stay the same. Hello. Not today. No, I haven't seen it. Oh, so on the list? Quickly, I'll check. 1 second. Yeah. 1 second. Hello. Oh, I have him key, but it's Fraser.
No, Fraser.
And,
Okay, so Brooklyn, we gotta find your class. Come with me.
and the other one. Sorry.
This is Cynthia Taylor.
Oh,
Yep,
yes.
you're Cynthia.
Huh?
Okay, can you go?
Hey. Oh, have a seat anywhere you want. Do you need a pencil or you're good? All right. Okay. Oh, always tell me when you come in. Okay. Or just grab one. Okay. So far, so good. So you said it does what? Nothing, right? So it stays as an 8. Perfect. And you do not show zeros. You show nothing because you're only allowed 1 decimal. Very good. Okay, let's see which row of the next 2 rows am I going to assign as homework. Come on. Look how quick you got into it. Again, remember, I do not mark homework. No, I don't even check it. But if you have any questions, lunch, break, whenever, before school, after school, I'm always here. Those are not as bad as the whole number, so it doesn't really matter which one I do with you. Oh, interesting. Let's do this one. It's the same number, right? But every time I'm asking you for what? For a different number of round. Sorry, for a different way of rounding. Okay. All right. So I'm gonna do this one with you. Okay. So the first one, 52 point or decimal point 3589. Okay. Here I want to show how many decimals. How many? No decimals. So where do I cut my line? Sorry, where do I cut my number? Right at the what? Right at the decimal point. Yes, right at the dot. Right here. The dot is still there, but it's being cut. All right. I look at this guy. What does 3 do? Something or nothing? Nothing, which means that will just remain as what? You're thinking of the whole number. So it's okay. It's okay. Things take time to sink in. Trust me. It just stays what as what? 52. Can you put 52.0? No, because that's showing 1 decimal. Yes, you got it. And you're not allowed to. Okay. How many decimals are you allowed to show now? 1. Hey, where do you move your line? 1 extra step. It's like a scanner now. It just keeps moving forward for every question. So let me zoom in. Yep. So 52.3589. Okay. Put your line right here. Oh, what's happening now? Are things changing? What do you think? Does a 5 change things? Remember, 0, 1, 2, 3, 4, don't. 5, 6, 7, 8, 9, do. Great. So the 5 will bump up the 3 to the 4. So this number will become 52.4. I'm using this example to show you that even though we're starting with the what? With the same number every time, depending where you cut, you might end up changing things or not changing things. Good. Let's keep going. 52, 3, 5, 8, 9. Of course, it's the same thing. But now my line is going to move After the 5, it's right here. What does an 8 do? Bump up. Bump, bump, bump. So this number will become 52.3 what? 6. And finally, 50. Sorry, that's not good. 52.3589. And where is my line now? Almost. I'm not gonna say at the end. Almost at the end. Almost. Not after the 3, not after the 5, but after the 9. What does a 9 do? Bump up. So 9 bump up. So this number will eventually become 52.359. Question, everyone. By the way, we're done for this lesson. Just one question though. Could I ask you, listen up, could I have asked you for another question for decimal places? Okay, hold that thought. I always love to ask what if questions. Okay, everyone? Look, 52. It's always good to think. I won't say outside the box, but extend your thinking. It sure does. That's why you have to know when to ask it. Okay, everyone. Where was our first line? Here, right? And it worked out. Where was the second line? Worked out. Third line? Worked out. Fourth line? Worked out. Why can't I ask you another question that places the line here? Because you always need what? Something here to do what? To judge what's going to happen to this guy. So no matter how big the number is, it can't go on forever. There's always what? A final spot after which putting the line makes no sense and no meaning. You got it. That's why. If ever someone asks you, why can't you just keep going forever? There is nothing to judge. I have no idea. If whatever number is placed here eventually by another teacher is 0 or 1 or 2 or 3 or 4, 9 stays the same. If it's 5 or 6 or 7 or 8 or 9, this 9 becomes what? It's interesting. What does a 9 become? But you can't put a 10. So what do you make it? You make it a 0 and this becomes a 90. Like you go to the next one. Okay? So that's why you can never do it when there is no more space to do it. That's basically it. Okay? And that's it for today's lesson.